In this chapter, we'll be going to see roots and coefficients of quadratic equations. To begin with, so let's recall some important terms first. First of all, you have the general form of quadratic equation will be in the form of ax squared plus bx plus c. So the key will be make sure that the coefficient of x squared will be a, which is non-zero, or else it may go to a linear equation. In order to find the roots, we may use the quadratic formula, which is a very complicated formula called minus b plus or minus square root of b squared minus 4ac divided by 2a. And next, so we need to revise the terms called coefficient as well as constant term. Let's go back to quadratic equation as example. And for example, we are talking about the general form is called ax squared plus bx plus c equals 0. And what's the meaning of coefficient? It means that a will be called coefficient of x squared. So it's like talking about the number which is next to x squared, coefficient of x squared. Okay. Coefficient of x squared. And then while b will be called coefficient of x in this expression. While constant term is talking about the number, normally we put in the end, which is independent of x, unrelated to x. So c will be a constant term. Later on, you may be seeing some question regarding to cubic equation here. So as a result, in this case, we have three different coefficients. One is coefficient of x cubed, coefficient of x squared, coefficient of x, and last we still have a constant term d in this expression. So make sure that you know the way how you read the coefficient as well as constant term, because they are important to our study about roots and coefficient of quadratic equations onward. Do you still remember the way how we can solve a quadratic equation ax squared plus bx plus c equals 0 by graphical method? Yes, that's good. So we need to draw two graphs. One is called ax squared plus bx plus c, which is referring to a parabola, as well as we need to draw the line y equals 0 or the x-axis in order to identify how many roots are there for this quadratic equation. And then so there will be three cases if you still remember. A quadratic equation may have two roots if it has two x-intercepts. A quadratic equation may have one root if it just touches the x-axis. And lastly, the quadratic equation may have no roots if it's totally isolated from the x-axis. But besides using the graphical method, is there any way we can judge how many roots are there for a quadratic equation? Now we make use of the quadratic formula that you highlighted in the box above, which is the following one. And in order to read this formula in a more clear way, you will see that roots x can be written in two separately. One is called minus b plus square root of b squared minus 4ac divided by 2a, while the other root will be minus b minus square root of b squared minus 4ac divided by 2a. To know how many roots that the quadratic equation has, it will be judged by the very critical expression which is in the square root sign called b squared minus 4ac. So let's take a look in the illustration as follows. So first of all, if you have b squared minus 4ac greater than 0, that means you can take this square root properly, or that means now you have two roots. One is called minus b plus, and the other root is called minus b minus. So that's why when you have greater than 0, then you know there should be two different roots, or we call two distinct real roots. This is the first case. The other case would be when you have b squared minus 4ac is 0, so this is the second case. You will see that the roots will become quite funny because it's minus b plus 0 over 2a minus b minus 0 over 2a. But indeed, they are the same roots called minus b over 2a only. So which means that now if you have b squared minus 4ac to be 0, then it means that the equation itself it has only one, we call one repeated root. So, or simply you say one root. Well, the last case would be, what if we have b squared minus 4ac to be less than 0? So you remember that when b squared minus 4ac is a negative, square root of a negative symbol, it goes to an error. So we can't take the square root of negative sign properly to get a proper real number. So that's why in this case, that means this one, it does not exist, or you may simply say that the roots are not real. Or in other words, we will say there are no roots, or more precisely called no real roots. So at last, you will see that the expression b squared minus 4ac itself is very critical to judge about how many roots are there for a quadratic equation. So that's why we give it a name, which is called discriminant. This one is called discriminant because it helps us to judge how many roots are there for a quadratic equation. So in conclusion, you will see that delta greater than 0, that means you have two distinct real roots. Delta equals 0, one root. Delta less than 0, no roots. So this is the summary about the value of discriminant. While as the expression, we will use it quite often. So that's why we also use a symbol to as an abbreviation, which is called delta. So it is a symbol of triangle, but it's also a Greek letter spelled as read as delta. So you can say delta is an abbreviation of b squared minus 4ac, and delta is the name of the symbol, while discriminant, you are talking about the expression b squared minus 4ac itself. So during the class or in the video, you will see that sometimes we use delta, sometimes we also use discriminant when we are talking about b squared minus 4ac. Now we take a quick look in the question as follows in the table. So do you remember what delta is? Yes, it's b squared minus 4ac, or you go back to the previous page to check for the formula. So in each question, you can check for the delta, so that at last you know how many roots are there, which we call nature of roots. So it's talking about how many roots are there for a quadratic equation. So for example, in number 1, delta will be minus 6 squared minus 4 times 1, which I omitted, and minus 4ac, c is a 4. So that's why it's 36 and 16, which is 20, greater than 0. So that's why we will say there are two, more precisely, we call two distinct roots, or two distinct real roots. So you can take time to check the rest of the examples by yourself properly. And next we come to some harder question, like example 2. Sometimes we'll give you a condition in order to find the coefficient in the question. For example, like the question tells you there are two equal real roots. So it hints you talking about delta equals 0. And now you have to find the value of k, which is the coefficient of x squared. So as a result, how we start, we can say delta is 0, followed by is b squared minus 4ac, which is equal to 0. So coming up next is 36 minus 8k equals 0. 36 is 8k, and finally, 8 will be 4.5. Not very difficult, right? Next one will be a harder job because it will be a bit challenging work for your understanding about coefficient and constant term. Because at first you will see that the question tells you that there are two real roots. So shall we choose delta greater than 0? Yes, some of you may say yes. But it's a very tricky word because two real roots, do you mean that two distinct real roots? Or you are talking about two equal roots? So that's why, as it's not clear, so that means both conditions may be correct. In this case, we will be writing as delta greater than equal to 0. So it will be a little bit tricky in this question at first. Next, can you see that there is a very special term called p minus 1 over there? So shall we consider p as together with x, or p minus 1 together? So this is the thing about how you understand coefficients and constant term properly. So let's read the thing one by one. Can you identify the coefficient of x squared? Yes, it would be your 9, because it's talking about the number next to x squared. Next, can you identify the coefficient of x? Yes, you search for the term with x. You can see there is only 24. And that's why 24 will be your b, which is called coefficient of x. P minus 1 altogether, so they are not related to x, so which is called constant term. So that's why you will now identify that in the question, indeed, it's talking about a is 9, take B is 24, while C would be a complicated expression which is called P minus 1. So that's why pay attention to the question itself, and you have to identify the meaning of coefficients and constant term properly. And now we can start part A after you identify the values of A, B, C. So now because of two real roots, so we start from delta greater than or equal to 0, followed by you have B squared minus 4A and C greater than or equal to 0. So it takes you some time to simplify the expression. So let's go ahead by yourselves. Okay, so next 24 square would be 576. Normally I will still keep the minus sign here, and then so simplify the things afterward. 9, 4 and 9, 36 will be multiplied to P and P minus 1, P and P minus 1. So that's why it's 36P minus 36. So be careful when you are simplifying the numbers in the brackets. And then followed by 576 minus 36P plus 36 will be greater than or equal to 0. Minus 36P greater than or equal to, so check it out carefully, is minus 612. And finally, you divide minus 36. And be careful that you have to swap the sign because you're dividing a negative number, which gives you 16. So this is the meaning of, you can also highlight it, it's called range of P. Because you're not talking about the value of P precisely, but you're talking about it's less than or equal to 17 in the question. That's part A, by initiating talking about two real roots over there. And then next, you see whether you understand the question. You have to find the root, that's your question, of the equation when P takes the maximum value. So what does that mean? Then you see that when P is less than equal to 17, it means that in the number 9, so you mark 17, P less than or equal to 17, that means it's talking about the numbers on the left-hand side. So what can P take if it is, for example, integer? So you may take 17 because there's a equal sign here. It may be 16, 15, 14, 13, etc. And when it takes the maximum value, so what value would it be? Yes, it's 17 because it starts from 17 and get the number and the numbers which are less than 17. So as a result, we will say first of all P is 17 as required in the question. And then as a result, the equation now becomes 9x squared plus 24x plus 16 equals 0 because it's P minus 1 here. Afterward, you may use your calculator and get the result directly, which is negative 4 over 3. Alright, so let's see whether you have any question about it. If not, I would like to give you a question. What if next time I give you a question like 9x squared minus 4x plus p squared plus p minus 7 equals 0? Can you help me to identify what are the values of ABC? My meaning is, can you identify the coefficient of x squared, coefficient of x, as well as the constant term? So let's take half a minute to do so. Okay, time's up. And you can see that it's very easy to mix up. Did you take 9x squared and p squared together because both of them as well? Did you take minus 4x and p together because they are talking about one single letter? If you did, that means you are confused about the meaning of coefficients. So when you go back to the meaning of coefficients in the very beginning, just talking about coefficient of x squared, you are talking about anything about x squared. It's nothing about the p squared itself. So that's why a, the value will be a 9. Similarly, the coefficient of x, which is the value of b, there's only negative 4. It's nothing about the value of p, no. So that's why the value of p is just a minus 4. While at last you will see that p squared plus p and minus 7, they are all unrelated to x. So that's why they are grouped and put together as the constant term. So let's see whether you have a better understanding about the coefficients as well as delta after this session.